Good morning, everyone, and welcome to join the Tampere Region Safety and Security Cluster webinar and networking session on digital twins. Um, I'm Anne Valtakari from Business Tampere, and I'm acting as the technical moderator in this webinar. A few practical instructions at this point. This event is recorded, and the recording will be available in Business Tampere YouTube channel tomorrow on Wednesday. And you will all get a link to the recording as a registered participant. And then about the questions, you can ask questions throughout the whole event through the Prella chat. And questions are handled after each presentation, or if there's no time left at the open discussion networking part in Prella starting at 10:30. Ja muistutuksena, että kysymykset voidaan ilman muuta esittää myös suomen kielellä. And so much for the general instructions, and now we can start. An opening words of this webinar will be presented by Petri Nykänen from Business Tampere. So Petri, please, floor is yours.
All right. Also on my behalf, you are warmly welcome to this webinar on digital twins. This webinar is organized by Business Tampere as the coordinator of the Tampere Region Safety and Security Cluster. And we had about 50% signed up for the webinar, and it seems like there's more than 30 now on the Prella. So clearly there is interest in the topic, and very nice to have you all here. This is one of the topics that we are actually last autumn or near the Christmas time, we asked from membership and interested companies, like what would you be interested to present on, and what you believe that would be interesting for others to hear about. So now we have this session on digital twins. If you look at the agenda, let me see. If you look at the agenda, we can shortly, and now we are in right format. So if you look at the agenda, we are starting with Juha Latvala on digital twins in industry, and as Insta is very much involved also in defense and other sectors, public safety and so forth, I believe this will be quite interesting presentation by itself. Then the next viewpoint will be urban rural development. So Jarkko Männistö from Sitowise will be discussing about digital twins in urban development, and I think they have also some interesting examples there as well. And then we have short break, and then Ananda Chakraborty from Tampere University will be telling us from the research point of view where the research on digital twins is going. And so we have three very interesting viewpoints on the same topic. Then after that, we will have short update on the safety and security cluster where we are, and a little presentation on that one. I will be having the presentation with Risto Honkonen and Mikko Koponen, Risto from Tampere University, and Mikko Koponen from Council of Tampere Region. And after that, we will have this kind of open discussion breakout room in the Prella for networking. So it will be more like a Teams meeting where you can ask for your questions and voice your opinions. And also at the same time, it's possible to do the one-on-one networking. And we asked from you when you were registering for the session that whether you are interested in networking, and almost everybody said that yes, we would like to network. So please use the opportunity now to have a look at who else are online and to discuss with them, and a little bit of reminder on the Prella, how you enable the networking in case you have skipped this. So please start the networking and indicate your availability for today. And then we have, based on the agenda of this session, we have the topics digital twins in industry, digital twins in urban rural development, digital twins in research, and you can sign up or indicate like that you would be interested to discuss on these. And in case you're interested to discuss on offering, or you have interest in digital twins as a customer, there's option for that. And then of course, as this is the safety and security cluster session, you have the opportunity to hear about the cluster operations, and in case you are interested in membership, so there's one option for that as well. And then as last item here, like indicate with short description who you are and what you would be interested to discuss about. What comes to the networking from schedule point of view, you can see that you can indicate your own network availability and networking availability, and we have, during the session, we have slots for all the times. So indicate at which times you are available. If you want to block some times out, that is as well possible. And then you just go to the people tab and start looking who would be the other people there. And I kind of set a target for you that please set up at least one-on-one. Look at the people who are there, and you have the possibility for this kind of a short one-on-one video call, and let's see how we can utilize this platform for our networking purposes. All right, but I think that the opening words are about done. We are now heading for the first presentation by Juha Latvala. So thank you all for joining, and have a good morning here with us.
Thanks, Petri, and good morning to everyone. My name is Juha Latvala, and I'll be leading you into the conversation about what digital twins are in industry. All right, you should be seeing my presentation right now. I'll be going through a little bit about the background of myself and Insta as a company and how we operate in this particular field. Then I'll be talking about what digital twin is as a definition and what it is in practice. Moving from that towards more practical how to create digital twins and how they have been created in the industrial side, and also some examples of what it looks like when you succeed. I'm perfectly fine with interruptions, questions, and if those persons who are on Umbrella and the Zoom could just drop notes or interrupt me at any point, please do so. Let's make this a presentation as useful and as to the point, specific to the questions and needs of the audience. Insta as a company builds solutions to gather, analyze, and lead with data. And this tends to be the norm or be the trend these days in the majority of the different industries. And the ones where Insta is specifically working is the Safe Society, meaning different health, emergency systems, and sensitive information network systems between municipalities and different governmental players. We also work in the defense sector with the Finnish military, and being one of the strategic partners for the Finnish defense. The largest sector, however, is the intelligent industrial side. And at this point, somebody typically asks the question as, what is the non-intelligent industry then? And maybe it's worth emphasizing that we focus on those industrial players that use both automation systems and software platforms to create value in their production. pipelines. So if we look at the topic of digital twin, you tend to get something like this as a definition for what is a digital twin. I mean, we're having a full day session about a digital twin, but if we would start by all typing up, this is my version of what a digital twin is, I'd bet that we would get quite a lot of different versions of it. A holistic, a generic version of a digital twin is that it's a created and accurate model, typically software, not always, but typically software, where we have implemented a functionality and behavior of a device or process to such a degree that we can both simulate and operate either on top of the real world version or on top of the virtual version, so that the results that we get are in practice indistinguishable, right? In practice, digital twins are strictly limited scope implementations. And the limitation comes in form of process accuracy, the environment in which the process operates in, different dependencies that have been taken into consideration, or different attributes that have been modeled. And I think it's very useful to start off by thinking about digital twins as lesser versions of the real world. And we only consider certain senses for that digital twin, either from a visual point of view, functional point of view, the kinesthetic version of how it operates, audio, orientation, spatial dimensions, and so forth. And this is super important to start off when thinking and talking now the whole day about digital twins, that they are always lesser versions, with some asterisks behind that. But let's consider them lesser versions of the real thing. And the most important choice we can make is to define in what areas those lesser abilities actually end up being. So to reiterate, there's really not a specific definition of the term digital twin that is valuable between companies or industrial solutions. We can talk generically about digital twins, but whenever we want to create real value, we need to come to term and talk about the boundary conditions and what we prioritize over other things. In practice, this is visible through these three angles. So the first conversation is the scope of what are we trying to model, twin of what and for what purpose. The second point is how do we want the model to work? So what are the characteristics of the digital twin we want to create? And finally, the realities of what kind of technology we have at our utilization and what it can measure, how it can measure, and how we should implement that. If we start by looking from a business point of view, typically, in majority of the cases, one of these 7 areas tends to be the leading driver for the necessity of creating a digital twin. Either we want to focus on the stability of a particular process, the productivity of that, or the resource efficiency of it. And these are the very kind of production efficiency-oriented values. Another triangle is the quality, safety, and sustainability of a particular operation and how well we operate in that particular dimension. And in the industrial spectrum, more and more, in addition to either of these kind of triangles, we get the predictability and ability to predict downstream of a particular process or through time what the value and production attributes would be. When we look at the technical environment, we tend to get a conversation about what is the existing environment and how should we then start approaching creating digital twin functionality. And there are many different ways of thinking about this, but one of the most predominant way industries have successfully implemented digital twins is to create, in addition to the existing production functionality, which is here called the system of records, where you have your ERP, MES, and automation systems. You create on the side of this a capability of cultivating intelligent solutions, and you transfer those pieces of information and connect only to that degree between the critical system of records and the system of innovation that is defined by the boundary conditions that are required or have been set for your digital twin. This choice of how you think about where you create the digital twin is actually extremely defining to what type of solutions you will get. Because if you start to operate on the side of the actual critical pathway, so the functionality that day in and day out functions at the heart and brain of your operation, there's very little wiggle room to actually make implementations and make modeling, because you need to you can't break the operation, and you can't fiddle with the operation while you're creating it. Whereas on the side of the system of innovation, you have the chance of benefiting from the billions of euro, dollar investments that have been made in the past 10 years into the different cloud and on-premise tools, capabilities, performance power of the big players in the world. And I would claim this is one of the most defining choices when a company starts approaching their desire to implement a digital twin. That do you end up operating alongside with a very difficult environment on the left-hand side of this picture in the system of records, or are you able to create a path where your development teams and your data scientists are implementing your digital twin on the right-hand side? Another way of looking at this, and the next kind of thing you need to choose, and this is really a choice, this is not an absolute outcome, is defining the right intelligence for your twin. And this is an example of a 10-minute, 1 minute, and 10-second drawing, not mine. It would look tremendously more horrible. I mean, there's a reason why I'm working in the technical domain and not in the arts space. But anyway, the degree and the intelligence of your digital twin varies and is a question you need to choose. Is the most right-hand picture accuracy of the real-world process you are about to make a digital twin of? Is the right-hand picture enough? It kind of shows it's a bird, right? Or do you need the left-hand picture, or even a more photorealistic version? And when we talk about digital twins, it's not just about the visual accuracy, right? Or actually very seldom it has anything to do with the visual accuracy, unless you're making, for example, rural planning, which I'm sure we will hear about in a second. But it's more a question of the intelligence level and the accuracy of the model you're about to create, which functions as the intelligence of your digital twin. I mean, there are those who have twins know that, you know, there are many different degrees of intelligence for your twin, and now you get to choose what it should be. And this is one version of describing how the intelligence varies and how you can choose different levels of intelligence for your twin. And if we start from the right-hand corner, these gray boxes, this digitized and connected boxes, they're the basic premise for anything for you to be, those are the raw materials for you to be able to say of which areas in your process you can actually create a digital twin of. Because the digital twin is a combination of the data and the access and the technology and the scope of the process you want to do, you need to have access to that data at a relevant interval and speed, and also accuracy. So you need to first be able to digitize the process and be able to connect to that data. That's the prerequisite. No value has typically been created at that point. After that, the 5 most commonly used levels or stepping stones for intelligence are the descriptive, diagnostic, predictive, prescriptive, and the adaptive or cognitive layers. Let's go through them one by one. In the first one, the descriptive layer, we talk about digital twins also in this layer, but at this level, your digital twin is about describing the process it has been modeled after. It gives you reports, visibility, dashboards, maybe rule-based alerts. But all of the choices, decisions, and higher understanding of what does it actually mean is left for the user, the workers, the different functions of your company or your operation. In the second box, the diagnostic box, we have a significant increase in the sophistication and the intelligence of your digital twin. Here, on an algorithmic and from a software point of view, you already have dependencies between different functions. You have correlations and causalities. So you understand how, from a software point of view, you have modeled how things work. You know, if we would be modeling a human being, you would know how the synapses fire, how the neural network works in combination with the muscles and tendons, and how that affects how your hands and fingers move. So you have an understanding that when a finger moves, what is actually behind the function of a finger moving. And in a production space, this gives you the ability to know, in addition to the efficiency levels, the overall efficiency indicators, or KNL values in Finnish, you also know why the numbers are what they are. And this provides your digital twin a capability of self-diagnosing on the fly. And this is an incredibly useful degree or level of intelligence for your twin, because now humans can do what they are best, so solve and fix things that are being pointed out by your digital twin, rather than simply getting a lot of data and trying to understand what all of that data means, because humans are not actually really good to understand statistical information and to peruse through a lot of data. When we go to the third and fourth layer, we get to an understanding that combines modeling and statistical information of past events to the degree where we can actually predict what's going to happen in a while, because we have seen the situations before and we know the characteristics of the process we're modeling. And when we go further from that, we can also turn it around and say we want to have certain kind of outcomes. And since we know the correlations and causalities, we can now define what should happen upstream in the process. And by upstream, I mean what happens before, and then downstream, what happens after the particular process we're modeling. And then we come to the degree where typically we talk about the AI solutions, self-adaptive systems, and there's a lot of different solutions and areas in this. The reason why I'm now going painstakingly, accurately, or in detail through all of these steps is that there's a bit of an issue right now in the conversation about AI solutions in digital twins. And the problem is that if we try to jump from the digitized or this zero-level intelligence directly to cognitive and adaptive solutions. Even if we're able to do it, it kind of breaks down because we have not created systematically the capability of describing, diagnosing, predicting, and prescribing capabilities for our processes. And this is the reason why in practice, not proof of concept degree of solutions, but in practice, what is happening in the industrial side, the most successful companies are working systematically from 0 towards 5 with these kind of very isolated things happening on the different kind of intelligence levels, but then most of the operations processes happening one by one, starting from the descriptive layer. So if we summarize, a good way of thinking about the digital twin definition typically includes a clearly articulated goal. So what is the purpose of the twin? Unlike in real life, in the industrial side, a twin should always be for a specific purpose, because you cannot have a generic good quality digital twin. Unlike, again, as in real life with your biological twins. The reason is that you can spend 20 years modeling and creating a digital twin for a combustion engine, one single valve operation. So you can more and more fine detail model and implement a twin. And at the same time, you can create a digital twin for how the whole world operates on a much, much higher abstraction level. So understanding for what purpose and a twin of what is the most fundamental thing for anything useful in practice to happen with digital twins. Rule set and processes, how we create the actual model and the level of intelligence. Measurement points, what kind of sensors does your twin have? Is it a blind model? Can it hear? Can it feel? Can it sense? With what kind of accuracy can it do it? And finally, how will we interact, we as humans and other software components? What's the capabilities of interacting with this type of digital twin? If we look at real life examples of how these principles and these definitions that I just went through, how do they happen in different companies? And we could start by Kiilto, construction and chemical product company operating in multiple sites in Finland, but also on the Lempäälä side, just next to Tampere. A tremendously well-doing company with a good mix of different type of products. They have over 1,000 different products. And what was modeled, what was created as a digital twin of the reality in their case was how does the production cost of individual products correlate to the volume of sales for that particular product and the margin of the cost versus the actual sales of that, and how does this view, this digital model of their product portfolio evolve through time. And if you think about that, you get into a solution where the model, the digital twin, maps and displays at all times how different products move through the volume, margin, cost space. And this provides very good capabilities for product management, R&D, to make choices about what to focus on and what type of functionalities should be done based on that implementation. Another type of solution, again, what is being called a digital twin, is creating a digital twin for a particular process that measures and defines the steam consumption. So raw material uses steam consumption in Kemira's case. And again, sometimes this happens that here the main driver was that we want to stabilize and we want to reduce the consumption of steam. But actually, to accomplish that, we needed to stabilize the functionality of a particular automation system, model that, and then guide that to become more stable. And as a consequence of that process becoming more stable, not only was the steam consumption reduced, also the maintenance costs and the predictability for any issues in that particular process were significantly reduced. And I think that was actually much more valuable than the original consumption of steam. In Boliden, Harjavalta, it's a ore refining process, and there's a production part that was modeled through 3 separate neural networks, so adaptive technologies and unsupervised learning. And here we got to a model and point where the digital twin of the actual process for the sulfuric acid production line functioned so well that not only could it predict what kind of values, production values, different type of parameters and inputs would create, when we turned it around for optimizing and reducing the amount of emissions, we got to an average of 5% on an annual basis. And these kind of percentages in the industrial side, these are huge deals. These translate to purer production, more sustainable operations. It's better for the company, it's better for the world. And I think one of the important things when we talk about business processes, there's this kind of, or at times there's this feeling that when we talk about optimizing business processes and production, people think that that would be bad for the environment, and that's not kind of the right way to go. And it's actually exactly the opposite. When we operate on optimal processes, the amount of emission, waste, and the consumption of raw material is minimized. Because from a production point of view, that's exactly how to optimize a process. So this was a great success in that department as well. These are the slides. This is the introduction to the topic of a digital twin in industries that I wanted to give. Here's the details for the 2 persons that typically are visible in the customer space from Insta. And now I believe we still have time for some questions or comments, either through Brella or through the Zoom link, if any. So please go ahead.
Thank you, Juha. This was really interesting. So, and Petri has some questions, right?
Yeah. Thank you for very good presentation. You mentioned using digital twins to optimize processes and to provide financial gains. I was thinking, like, do you have examples on or how do you see what are the opportunities in creating digital twins to enhance safety or security in the industry?
Safety and security tend to be more of a trigger value, or this kind of we do not, or an optimized approach is that we don't want to have issues and problems in these particular areas. And it's very often about defining and finding trigger values that we want to stay under. So from a modeling point of view, we tend to monitor incidents, potential issues, near misses, and kind of warning areas, and find ways of modeling that, and then using that as a basis to create a security and safety digital twin. So essentially, you could say you create an artificial entity that is only interested in the safety and security of a particular environment. And then that digital twin its purpose in life is to model all of the potential areas that might be problematic in this field. This is being done, and often it's not coming out as let's optimize this in the industry. It's more how do we maintain the required degree while at the same time we increase the speed or the production output of a particular industrial process.
All right, thank you. Now I want to point out that if people are in the Prella looking for where to provide or make the questions, you have to go to the Streams tab. So if you are in the event home watching the video, you will not see the chat screen. But if you go to the Stream tab, you will see the chat and you can provide your questions. And while maybe waiting for a minute for the questions to come, I would ask another question that how do you see, Juha, on what level we are in the industry in taking digital twins into use? Is it just on the first steps or it's already widely used? How you see where the industry is today?
Do you want to get the answer on this slide or this slide? So just kidding. From a statistical point of view, 85% of companies in Finland are in between numbers 1 and 2. So the vast majority is describing their own situation. I'm having these conversations with 50 or 60 companies a year. So already based on that, the message is pretty similar. So the answer is that yes, we have reached the stage where we have digitized majority of our relevant systems and operations. We have connected them in such a way that we can get information. And oh boy, are we getting terabytes of data. We're a bit struggling with what to do with that terabytes of data. In majority of the cases, we have dashboards displaying some interesting information. In some very specific cases, we have created models, more accurate models. And then we have a whole host of companies working with us where we have made proof of concept trials of predictive, prescriptive, or adaptive systems. But we're still trying to find a way of systematically move towards those more sophisticated solutions.
Right. Okay, there seems to be no additional questions on the stream. So thank you, Juha. And just a reminder to everybody that at 10:30, when we have the networking open discussion breakout, you can also state questions there later on to Juha. So Juha, you will be offline for an hour and back for the 10:30. So just to indicate people that you will be back. So please think of good questions for Juha. But thank you for the presentation.
Thank you very much, and also bad questions are allowed. Let's figure out and answer that. Thank you.
Thank you, Juha, and thank you, Petri. So we go forward, and our next speaker is Jarkko Männistö from Sitowise with the topic Digital Twins in Urban and Rural Development. So please, Jarkko, floor is yours.
Okay, hello everybody. I'm starting to share screen. Hope you see that.
Yes, it's perfect.
Okay, thank you. So my name is Jarkko Männistö, and I come from Sitowise, and I'm going to tell something about digital twins, more in digital field environment and how we create those digital environments. From my side, my backgrounds are in traditional architecture, but I have been working with 3D modeling about 25 years, Now, past 10 years, I have been working with information modeling, information management, of course, also in visualization, but now with the game technologies are a big part of my career nowadays. Something about Sitowise. Here you can see some our key features. Sitowise operates in 4 countries with more than 1,900 employees in 29 offices, and we have almost 90,000 projects behind us. We provide almost all built environment expertise from planning to consultancy and digital services. And our main business areas are real estate and buildings, infrastructure, and digital solutions. So we provide extensive services for the needs of prosperous living environment, receivers to diverse and varied expert services and digital solutions for the different life cycle phases of properties, buildings, and infrastructure. So in this slide, we can see how a real world and city environment transforms to 3D geometry and to visual window of data flows in digital twins. I can't give a straight answer what is digital twin, but I can show use cases today and some topics of needed materials and designs to create 3D environments of digital twin. My opinion is that we live not in 3D environment, but at least in a 3D plus environment, because our cities are dynamic and full of activity and mobility. We have people and traffic. Our environment is also more like a 360 view. What happens front us or behind us. This video helps us understand what happened in our own environment, place, and space where we live, and how digital solutions will change our behavior, how we make perceptions from our environments, and how we interpret it. Human scale, eye view, and speed, how we move from space to space or exterior to interior are important ways to make perceptions in city environment. The availability of data defines the quality of the digital twin, and in digital world we can find more dimensions than our 3D real world. So today I'm going to show something about our services, which is a digital twin platform, and how does it become a live, collaborative, and smart solution. But something about source data, how we create digital built environments. So we have a different accuracy of source data, and we call them a level of details. LOD1 means that we have a terrain surface with orthophoto. LOD1 means about that buildings are just boxes without complex shapes, and they based on footprints of base maps, and height indicates average building height. LOD2, we have a shape of roofs based on often aerial laser scanning or point clouds. And what I can say is that from 0 to 2, we can get this data from national or municipal or city level data. And this means that this is more like a GIS data. What becomes to LOD3 and LOD4 means that we can get this data from designing designing data from buildings and also in infrastructure data. LOD3 means that we have in buildings we have openings like windows and doors or balconies based mostly in mobile scanning or point clouds. And LOD4 means that we have inner walls and floors. So basically, I can say that the 3D model or digital static environment is just the top of iceberg. Our digital built environment is always dynamic. As we see, there is a lot of mobility and traffic inside that. But above that, we can create different design and analyze tools. We can create different kind of simulations, but also this 3D model makes possible to create a platform to digital twin, where we can take to connect to IoT or sensors and present real-time data. So we have a connection to real world. So where we can start is that we create this GIS-based 2D map service, and what we can get from that is that from GIS data we can get building information, we can get real estate data, we can get building information, volume of areas, addresses, use of buildings, and so on. This is example from the map service from city of Vantaa. Also, we can get information, not just basic 2D information from traffic, parking, temporary driving routes, or traffic lights, speed limits, or even design tram routes. But when we are creating 3D world, we can also give more information in the visual part. So here we can see how the 3D information and textures give us same data in as 2D, but this is more visual appearance. And when we are putting orthophoto to the terrain, it comes more like a 3D visualization. But also it has a lot of data behind that. So we can get data from buildings or streets, etc. So this works quite like same that's a 2D map, but this is more visualized model. So to create 3D visual 3D environment, and when we are going to LOD3 and LOD4, 3D city models means more like existing states of cities, and also it is GIS information, but this BIM, like I said, building information model or infrastructure designing, we can get more information from structures and then building volumes. In this flowchart, we can see data flows from initial data or source data to virtual reality solutions and different publishing platforms. What we did in Pasila, this is example one case we have done late or past 5 years, that we collect all data from designers, we create a technical combined model. We create information management regulations, how to put metadata to these information models. We create reference points to local coordinates, like in building. When we are designing buildings, they are more like in a local coordinate system. So we need reference points to put them in a global coordinate systems, and also we create data logs where we can get who has provide this design data. So then we go to the digital twin system. Like I said, real world is a continuously changing environment then that can be observed and controlled by sensors and cameras, actuators, and people. This 3D environment can be directed with screens, displays, and smart applications. This flowchart is from our port of Oulu case, and it gives some ideas how complicated our future digital world is. I don't go any deeper of this, but this is what we call digital twin system in deeper context. And it's data connections between real world and digital world. It's an IoT key of digital twin system. Also, this digital twin could be also a communication and a communication tool. Our service is a digital twin that creates an understandable and visual 3D environment to help different stakeholders, designers, and decision makers and citizens understand the changes in the built environment. From one model and service, we can publish to traditional end products like videos and visualizations, and it also enables the use of new technologies like VR and AR. And this is a screenshot from our service in a Pasila area based on those combined models, designs, and GIS data. And this Pasila, as you know, it's in the heart of city of Helsinki. So next I'm going to say a few examples what we have done lately to create digital twins. I'm going to show a simulation tool in 5G network, lighting, surveillance cameras, and traffic. Also, what kind of information we can get from buildings or smart city objects like lamppost, etc. Also, how intelligent is our buildings nowadays when we are creating these designs based on information modeling. Also, it's real important to show how these environments change in future, what kind of information or data we can get from mobiles or sensors. And here we can show previous slides how they work on video and what we have analyzed and simulate in those digital twins. So I can say that this is some kind of digital observation deck with the examples of those simulations and smart buildings. And it's the important part of this simulation tool was combining and utilizing like underground infrastructure in the design of lighting poles, smart buildings, and also the base station of 5G network. So like in the left side down, this was the first demo from Aalto University building. In this project, we create a smart building by utilizing the building information models and combining the location of equipment of structures with the real-time data or HVAC machines. And also in the right side down, we can see when the how passengers moving to automatic bus or how the vehicle reacts in real time to surrounding devices and receives information about other traffic and weather data. So here we can see our environment is dynamic and full of data. Actually, this case we did also in Aalto University environment. This was the first lighting simulator we did about 5 or 6 years ago, and this simulator give also real-time connection to smart light poles, and we can change with this like a range of light, color of light, etc. Also, we create a smart lighting system inside this when cyclist or pedestrian approach the lighting pole, the light goes up or down, depends how close this cyclist or pedestrian is. And this is now what we are working in actually in Kera-alue. Those previous examples you saw have now taken steps further, and this environment has become more accurate. As you see, it's based on point clouds, and also our city objects are coming more intelligent and a part of real-time data sources and digital twins. Then a few examples what we have done lately. This is case of Tampere and Tammela district, which is a part of a 5-star city center. City center of Tampere has been divided, as we know, by railway tracks and station model. So how Tammela area will connect to western parts of city center. This is also a snapshot of different design phases of designing, like conceptual designs, city planning phases, design stages, IFC model based on building permission processes, etc. I think that the developing cities is always a timeline. What is now, what happens next, and far away future. Districts and our own neighborhood need to be comfortable, lively, and safe all time. This model has shown in a virtual cave premises in the city of Tampere to designers, citizens, and housing companies. This case is from Port of Oulu, and this is example a real digital twin case in northern Finland, where we have created real digital twin in port area based on, again, building information models, GIS, and design data, and point clouds. Actually, we created real-time data connection to weather data, ship data, grain data, and data of transportation. This data analysis to optimal routes and find time savings from grain movements. We are next to see how this grain moves when this ship approach to the port. Also, this model makes possible simulation of like drones, surveillance cameras, safety issues, smart lighting, etc. And in the port of Oulu, this digital twin is a part of a digital infrastructure with dynamic and interactive 3D platform. And what we can get, it improves efficiency, reliability, and communication of port operations. And like here, we can see how we create a heat map of grain movements. Also, we can, with this history data, it allows operational planning, predicting, and simulations. Next case. This is from Tampere and Hervanta area. And again, we created this 3D model based on data of city of Tampere and their own information, city information model. And here we can see how we create also a 5G network simulation to a test route. Okay, and finally, I'm going to show some future views from a Recotect event. This was 2019. We brought our high-end virtual 3D city environment to Varjo VR classes and showed a new way to design and observe public space. This our pilot area was again front square of the new Aalto University building, and we used the most advanced and accurate VR headsets of Varjo. With the eye tracking, users were able to change color temperature on lights or change ground surface material. Also, users were able to get information from smart city objects. After this VR session, our solution made a 3D heat map from user's eye view. This was really interesting tool to observe 3D environment and how we see it. What are the interesting targets and can we find guiding to move in unknown places? I think that this can be predictive planning and designing process in future. So my time is now coming to end. So here is a couple links to our solutions. If you have any questions after the session, please take a contact in Umbrella. There is also, I hope that there is also Timo Karjalainen from our company to give answers what we have done and what we can create in future from these digital twins. Thank you.
Thank you, Jarkko. This was really interesting as well. So, Petteri, do we have questions for Jarkko?
We have a couple of questions that we kind of spin during the presentation, but please, like audience, as you are watching this, like in the stream tab, if you have questions, you can state them and we relay them to Jarkko. But Jarkko, very good presentation. Thank you. I have a couple of questions to warm you up on this. So what are the obstacles you see for wider use of digital twins in urban planning? And if there are such, like how to tackle those challenges?
Well, there is always obstacles. Like when we are creating these 3D environments, it's not a straight timeline from these information models to create these visual platforms and digital twins, because there is many ways to create information models, and so we need the straight data, like what are the walls and what are the windows, etc. And this is what we need to improve in future, how we connect to 2D data to this design data and etc. So I think that the most important thing is that in future information modeling in design processes coming more and more accurate, and yeah, I think that's the most important thing. I think.
Okay. All right. Then another question on you mentioned there like a 3D gaming environments. I assume it's like Unity and Unreal or this like the leading
yes.
one. And then you had like many examples where you had this VR visuals or glasses, and like kind of a question is like is this like, do you see that like the urban design or planning is kind of the potential really use for the VR, as that is kind of looking for the right use case to take off, but like in your industry and thinking of solutions like Vario has, like what do you think of the opportunity or the potential?
I think that there's lots of opportunities in VR or AR or even mixed reality. So like you saw in this Vario case, we use these Vario classes as a designing method. So we can create routes, how we move in a digital environment. It could be a predictive planning. So how we are guiding ourselves, etc. So I think that when we are headsets coming like everyday tools, then this gaming environment, it's easy to put those devices. So I think that it's now we can use it, but it comes more it's easier in future to use these technologies, I think.
Okay. Maybe one last question on, like, you had very good examples from many cities, and you have been involved with the city like 3D models, and in a way thinking of the 3D models of the cities as a repository of data and how that builds up, like how you see it where we are in Finland, like thinking of Helsinki, Vantaa, Tampere, Oulu or so, and kind of are we moving from this one-shot projects to actually building the repositories so that it would kind of accumulate the information over time? Because like when we discussed last time, I think that there has been like kind of a concern that they are kind of individual projects that are built rather than building the repository. But like, what's your take on that? Where we are in the cities currently?
Well, we have created these models basically in biggest cities in Finland, but I think that in future smaller cities can participate also this kind of concepts, because we can get data from national data. We can create these environments from the smaller cities, like drones are coming more useful to take photogrammetric photos, and we can create 3D environments more easily in future. So I think that yes, I think that's a simple question. It becomes more useful in future in whole Finland.
All right. Thank you very much. I think there are on the chat no questions, so we will go with these. And thank you, Jarkko, for a very good presentation.
Thank you.
Thank you both, Jarkko and Petri. And we are now having the 5 minutes break. So let's continue in 5 minutes. And then we have Ananda Chakraborty from the Tampere University telling us. So let's come back in 5 minutes.
According to many statistics, Finland is the safest country in the world. The Tampere region is home to the country's largest international significant clusters of safety and security experts, consisting of more than 250 separate entities. Safety and security is created in many different industries, and many new innovations are created by combining the know-how of different industries. Safety and security is often invisible, but insecurity is visible and felt. Tampere is built around industry and is one of the most important industrial cities in Northern Europe. With the development of industry over the centuries, innovations in industrial safety and security have also been developed at the same pace. High industrial safety and security expertise is strongly associated with tradition, which is further enhanced by excellent universities. The Tampere region offers various safety and security solutions for factory environments, as well as for the needs and operating environments of other sectors, such as ports, mines, the forest industry, and energy plants. In Finland, safety and security is top-notch. Tampere is known for its major industrial machine builders, in which safety and security aspects are incorporated into the processes, products and services, and work environment. The industrial internet has been an integral part of Tampere's safety and security expertise. Many of the companies operating in the region are pioneers of digitalization in their respective industries. Safe and secure by design. According to many statistics, Finland is the safest country in the world. The Tampere region is home to the country's largest international significant clusters of safety and security experts, consisting of more than 250 separate entities. Safety and security is created in many different industries, and many new innovations are created by combining the know-how of different industries. Safety and security is often invisible, but insecurity is visible and felt. Finland is a pioneer and an international example of a country where excellent cooperation between authorities is carried out for the safety and security of society. Trust in the police, rescue services, and defense forces is very strong here. Safety and security solutions are often integrated into society so imperceptibly that everyday life is safe and free of disruptions for Finns. In the Tampere region, many companies have developed significant nationwide solutions for a safe and secure society, for the benefit of both authorities and residents. The solutions developed in the Tampere region emphasize close cooperation between different sectors. Authorities, companies, and citizens alike have been involved in the development. The solutions developed here are full of potential for the global market. Safe and secure by design.
Okay, welcome back from our short break. And our next speaker is Ananda Chakraborty from Tampere University, and his topic is digital twins research. So please, Ananda, floor is yours, and you can start sharing.
Yes. Okay, can you see my screen?
Yes, we can.
Hello, I am Ananda Chakraborty, and till now we have seen very good examples of digital twins and how digital twin is use cases of digital twins. In this talk, I will try to present a little bit about the research aspect of digital twins and how the academic community see digital twin. I would like to start by saying a little bit about myself. I am a researcher at the moment at Tampere University. I have been involved with several kind of projects for the last 7 years now, and most of them are around industrial IoT, IoT in general, and recently in the last couple of years, digital twins. So in the research community, I have seen, at least in the last few years, how digital twins kind of evolved, starting from IoT to going towards industrial IoT, dealing with proprietary protocols, and then towards digital twin. So it's worth to say that starting a digital twin project requires this underlying infrastructure of any company, any organization, any machinery, where there has to be a data collection framework, deployed sensors, a method for collecting the data, storing, analyzing, and applying predictive algorithms, machine learning algorithms. And then when we can integrate good simulations with it, then we can call it a digital twin in theory. So the evolution of digital twin revolves around two concepts, has always evolved around two concepts, the physical and the digital. So to make our understanding very clear, the physical doesn't have to be a physical product. It can be a concept. It can be a representation of a product. It can be a simulation. And the digital would be the interpretation or a mirror image of that, having some dimensions. So if we consider a machine, for example, like a grinding machine or a mobile machinery, a diesel engine, something like that, then the physical could be considered as different sensors, different actuators, and also in the parameter level, the temperature, pressure, flow, all these variables. That could be a representation of the physical as well. And then digital is the continuous stream of data that we are collecting of these physical parameters to create an image, a digital image of that physical entity. So rather than saying just a physical object, I have seen that in research community, people prefer using the term digital entity and or virtual entity and physical entity. So rather than objects or a piece of software, entity term is quite largely used. To talk a little bit about the background of digital twin, in 2003, a guy named Michael Greaves, he was working in Florida State University at that time, he proposed the term digital twin. However, digital twin was actually realized by NASA in a 2012 paper, where they tried to model a three-dimensional representation of a rocket. And later in 2019, a Chinese guy called Fei Tao, he came up with five-dimensional representation of digital twin and how we can perceive a digital twin as a mix between this physical and the digital entities or versions. So there, to call it a digital twin, we can have the physical version, the digital version, and the data that they exchange. So if you want to call it a three-dimensional digital twin. However, the concept was further extended to include the different connections they share, the physical and the digital, as well as the services they provide. Now the context in 2021, I would say, the concept has entirely started or initiates with the services that digital twin provide, and it's the correct direction. So the purpose of building a digital twin becomes important, and then the other dimensions fall in place in order to construct a digital twin as such. I often find when I talk to my colleagues or people in the companies, I find that there is a confusion of when to build a digital twin. What exactly is the requirement to start building a digital twin? And I think this is a good representation of how we can come to the conclusion that yes, we need a digital twin for the application. So on the x-axis, you see the physics, the understanding of the physics of operation that we possess of the component or the machine. And on the y-axis, you see the data, amount of data that is available. So now, when you have low understanding of physics of the system, and you have low amount of data from the system, so in that case you will build something called as a knowledge base. So it's the representation of the system's knowledge. If you have low physics and high amount of data, it is the top left corner where you will go for machine learning and AI and data-driven methods and to build data-driven models, because you possess a lot of data about the components without an understanding of the classical physics. If the situation is reversed, if you have less amount of data and more amount of physics-based knowledge, then we technically build simulation models, like, for example, finite element model or computational fluid flow, those kind of models which are physics heavy, but not too much of data is available of the system. However, when you have an excess of both, or rather good understanding of the physics and required amount of data, high volume, high variety data, then you will go into the top right corner, what we call as the digital twin. So this is a way of understanding when should we rather build a digital twin. So the way I see digital twin in today's day and age, it has two components. One is the industrial IoT part, and then an advanced simulation models, for example, physics-based or even system-level models. When you put them together, then you can technically call it a digital twin. So for building a digital twin, these two infrastructures should exist. One is an industrial IoT compatibility, and the other is advanced simulation capability. Putting them together can form a digital twin. Now, we understand the advanced IoT part. We have distributed sensors, we collect data, we have databases where we store, analyze the data, apply machine learning algorithms to make some predictions. However, on the simulation side, it is, again, there are, you can build several models. You can build a thermal model, you can build fluid models, you can build dynamic models, electrical models, system level models. But the question is, if my purpose is to evaluate the safety of the system or working safety of the system or performance of the system, then I will not need all sorts of simulation models. So if I am looking for some thermal characteristics, then probably I will not need an electrical model for it. So the thing is on-demand modeling, not just one model, but the right model at the right time. So if I am interested in the dynamic characteristics of a mobile machine, the dynamic model should be that should become the most important aspect of the digital twin, and so on and so forth. So the overall capability that we have performed here in Tampere University and with other company partners are these. We have smart sensing capabilities, connected hardwares. We have deployed different kind of hardwares, built control systems to control at the machine level, as well as export the data over to cloud or on-premise servers, and then analyze those data in order to find out some specific information that the client is looking for. We deal with open and fast source communication protocol standards. It is in research at the moment. 5G is coming up in a big way in research area as well, and that has a huge impact on digital twins and their development. Advanced analytics, machine learning algorithms, AI capabilities is also something that we deal with. 2D and 3D simulation modeling, it is kind of a strong point of our department at the moment, and building digital twins based on 2D, 3D models, then building safety system level models for evaluating safety of the system, evaluating performance of the system, and so on and so forth. And finally, digital services, which is the pool for the entire string. So the main idea is to provide certain services which the client needs or demands, and the entire thing is threaded according to the service that is required. One example is a forest machine case that we were working with for more than 3 years now. So this kind of represents the capability that should exist underneath in order to build a digital twin. So in a forest machine like the one that you see on the right corner, it has deployed embedded sensors, and from that we collect the data about different pressure levels, temperature levels, flow patterns, movement of the boom up and down, so on and so forth, when the head motors are on, when the cutter is on. So we collect all those informations. We collect the data from the sensor with the help of CAN bus. Then we write our own embedded systems in order to package this data and then move it over to a server, which could be on premise or in the cloud, depending on your needs, and then apply some analytics on this data in order to find out some details about the operation. And we develop these kind of dashboards which gives several information about the system that is working. So this sets a ground. It sets the underlying infrastructure on top of which a digital twin can be imagined. So with the IIoT part on one side, that is the left side of the picture, it's the same picture as the one from before. And then we start building models, system level models, or engineering models, CAE models, CAX models, and then integrate the data that is coming from the field with these kind of models. Now, in my opinion, the most challenging part is how to design effective interfaces. So in theory, we have good understanding, and also in practice, we have good understanding of how IIoT works now, how we can collect data, how we can create repositories of historical data, and so on and so forth. And we also have a good knowledge of how to build system level model. But at the moment, the research challenge, one of the several research challenges in digital twins would be how to define effective interfaces so that these two can seamlessly interchange information, and the digital and the physical shares information in a seamless manner. So this is one of the challenges, in my opinion, that we are facing in digital twin development. One way to do that is with the help of something called as model reduction or reduced order models. This is kind of a state of the art in the academic side for digital twins at the moment. So now we have a data collection infrastructure where we are collecting enormous amount of data, and then we have these models which could be very simplistic models to very complicated models depending on your application. And now if you have a very high fidelity model which tells you a lot of things about your system, ideally you will go for that kind of a model. However, one challenge is to integrate and seamless data exchange. And for that, one discipline that is used nowadays is called model reduction. We try to compress the model, the simulation models, into smaller representation. Now, the smaller representation should not lose the very important characteristic of the bigger model. So it should capture the essentials of the bigger model and give you a small compressed representation which has a lesser size that can be deployed as a unit, as a functional mock-up unit in your cloud or server environment, wherever you are hosting your applications and you're getting the data from the field. So the method is the method that we follow, or this is our method that we developed, is taking these kind of bigger bulky models, running through reduced order model algorithms that we developed, and compressing them and exporting it in the form of a functional mock-up unit, or FMU. And this FMU can be shared with the standard called as FMI, which is FMI 2.0 is the current version. So with functional mock-up unit interface, this FMU could be shared into the cloud environment wherever your IIoT device is posting data. For example, if you have a ThingWorx cloud for your company or any other cloud environment, it is possible to deploy these FMUs in those cloud environments where your IoT devices are posting data. So you have these services, you have the API design, you have the APIs which the IoT device is consuming. So it's basically the same location where your reduced order model is deployed, as well as your APIs are consumed by the IoT device. So creating one point where you can integrate all of them together. Some cases that we are working on, or the projects that are going on in university at the moment, based on the idea that I have been talking about, is DigIt. This is a project that was started in 2020 for 4 years. It's a Horizon 2020 project. And we have 16 partners at the moment from 9 countries working on different aspects of making safe and sustainable mining practices. So in this project, Tampere University, we are participating on the mobile machinery side. So we are collecting data to from the machines, from different machines, which are in Norway or in Finland. And then we send this data over to an aggregator. This aggregator is developed by another partner, where other partners are also pushing their data. This data comes from different aspects of the mine and their operation. For example, there are geotechnical data, there is air quality data, there is machinery data, there is fixed machinery data, there are human data from smart clothing. So you attach different sensors to the guys who go down in the mines and collect different data about their breathing, about their heart rate, and so on and so forth, and bring all this data together over to an aggregator. And from that aggregator, you can fetch the information what you need and develop digital twins of different aspects of the mine. So that is the target of the project. So this is one digital twin project that is going on at Tampere University at the moment. And the main idea is to make mining practices more safe, secure for not only the workers, but the machine operators and everybody else involved in the mining operation. Our second case is an older project, but still it's one direction towards the digital twin. It's an S4 fleet where we deal in the machinery level. So collecting data from different machineries with tags, flow tags, and other sorts of sensors, vibrational monitoring to understand the risk of their failure, how they are running, if there's some problem coming up in them, if there is a delivery risk. So if you have a deadline and some machine is not operational, or can it happen that it would become non-operational in the coming days and you are not able to respect the delivery date. So this kind of bottleneck analysis could be done, collecting information from different machines and then providing it in a digital form to the clients. So this is an on-demand. So it is, the entire thing is web-based. So you have a URI where you can go and see your entire plant's operation. So if you have a tablet or a smartphone or a computer, you can visit there and you can monitor what is going on. And obviously here access control and all those things becomes important. Where the company wants to provide their data, only those people would be able to see. So accessing is also controlled with username, password, and all sorts of security features. And finally, I would like to discuss about digital twin environment for grinding, the grinding machine. This is also a project funded by Business Finland in Tampere, with Tampere University, running from 2019 to 2021. It ended really soon, and this project, the idea was to build a digital twin environment for grinding, the similar kind of grinding machine that you see on the left. Here we came up with a concept of 5-dimensional conceptual digital twin. So not just putting technologies together, but what makes sense in these contexts. So physical entities representing different parts of the grinding system, virtual entity. That's why I like to use this word virtual entity, because it is not just one model. In my opinion, it's a collection of models. So there are geometry models, there are physics-based models, behavior, rule-based models, AI-driven models. So this entire representation, mixed representation, is basically my digital twin. So that is the virtual entity. And then we have the services, different services that this grinding system will provide, and the data that they exchange and the connections. So putting all these 5 dimensions together to form a complete digital representation of the physical. So if you can put a globe over all these 5 things, that would be an ideal digital twin solution for that physical entity. And this is an ever increasingly important topic, that is application of AI or role of AI in developing digital twins. The way we see AI is we try to find causality with different machine learning algorithms. And in the grinding case, we also try to do the same, trying to find causality that what component might fail at what time. Can we collect data of the normal operational grinding process and then predict that a variation in temperature or a variation in grinding speed is indicating what? So in theory, this is called sensitivity analysis. So we try to do sensitivity analysis with machine learning models in order to find out that how these initial parameters or these dependent and independent parameters vary. And what does this mean? So if there is a change in temperature or change in grinding speed or something else, can this lead to a situation which will cause a failure? And then we will start taking actions in order to prevent that, to take it away from a failure situation. So this is a fast growing area in digital twin research, and that is application of AI in digital twins. Okay, so I had this to share at the moment. If you have any questions, I would be happy to answer. Thank you.
Thank you very much, Ananda. And Petri, was it so that we had some questions?
Yes, let me check how the video is running. Yeah, there was something with the Prella and Zoom at the same time. So Ananda, thank you for the presentation. Like the forest machine case was very descriptive, and also these other examples as well. Thinking of the research, what is the focus on research worldwide? Where or on what topics are the most papers now published?
At the moment, I see research community, it again, if you go from the conventional mechanical sciences, then the focus is more on this model reduction and how to compress a very high fidelity model, especially finite element model. So in a machine, for example, just collecting the data or just having a representation of it does not make much sense. We are more interested in knowing the physics behind it. So how is some temperature distribution leading to stress? Are there incremental stress growing in components? So like that. So that is why we build very high fidelity model. These finite element model can run for 2 days, 3 days in order to give you the desired or the solve for the values that you're looking for. So these are very complicated models, and building a digital representation of that and connecting them with the data, it is extremely difficult. And we are talking about enormous amount of computing power. If we have to compress a model which runs for 3 days in 3 seconds, for example. So that's why compression of these models and reduction of these models is an important topic in research, I see, at the moment.
Right. Okay, thank you. And we will have like later on the breakout room session, so we can ask you more questions. But like, thank you, and let's move on the agenda.
Thank you.
Thank you, Ananda and Petteri. So we continue to our last presentation, and that's Tampere Region Safety and Security Cluster Update. And the presenters are Petri Nykänen, Risto Honkonen from Tuni, and Mikko Koponen from the Council of Tampere Region. So please, gentlemen.
Thank you. Is the screen now visible?
Yes, now it's visible.
Okay, very good. So this is basically introduction and update on the Tampere Region Safety and Security Cluster, and we have kind of restarted the webinars. We used to have this kind of morning coffee breaks or so, where we had the presentations, but like now we are online for some time at least. If you look at the region, like we could say that the Tampere region really has significant concentration of safety and security know-how and organizations, and these are coming from kind of organizations are from different sectors or so. We have various businesses that are active on safety and security here. We have the non-governmental organizations like Red Cross or the voluntary fire brigades. We have the public sector that is on one hand the authorities, but also municipalities, and they have a strong role in safety and security. And then we have the research and educational institutions. And if you look at the region, like thinking of these institutions, the Police University College, the National Technical Research Center, VTT, Tukes, the Finnish Safety and Chemical Agency, as well as Finnish Defence Forces, all have national role and on one hand, and on the other hand, they are very strongly present here in this region. And of course, we want to see how these different organizations could have synergies and build something more together than what they do alone. And the kind of a platform that we have for this collaboration is the Tampere Region Safety and Security Cluster, and that has been now in operation almost 10 years. If you look at some of the examples on the know-how and innovations made here in this region, this is just a quick selection of some of those. Some are still in the works, and some have been established already. But like we have here like examples of this kind of a situational awareness solutions. By instant, also Patria is working on the National Common Authority Field Command System. Solita has built the National COVID mobile application. DGI is involved in digital identity for national passport and identity cards, and as well as for 112 Finland application, Suomi application for citizen emergency response. Insta has built ERICA, the nationwide emergency response center information system, and that is the business is being transferred to Cinia as we speak. And then on the healthcare, we have Atostech with their interfaces to Kanta, and Cinia with their platform for safe and secure communications for authorities. All of these are just examples, but I think they also show that the Tampere-based and the region-based companies they have kind of a wider footprint than only Tampere or even Finland. We do recognize that Finland is not in the Central Europe, so if we think of the goals of the cluster, we want to strengthen the region as nationally and internationally recognized concentration of safety and security knowledge, and we want to operate both in national and international networks. And we see this as a benefit in two ways, that the more our region is known for its know-how, the more we get contacts from elsewhere and opportunities for our companies and organizations for collaboration. And also we want to see that the enterprises, the companies that operate in the region, they can build solutions and export those. So building solutions for more than Tampere region, for more than Finland, but the whole world as the target. In nutshell, if you look at the safety and security cluster, as I indicated already, it's established 10 years ago, 2011, and as noted, we have several of these organizations also with national role present in this region. This region has its historical kind of reasons for being central for safety and security, being optimally located and having the industrial background. The defense sector has been strong in the area and so forth. What we want to do is to tackle local, national, global challenges and do that through the collaboration of different parties here and elsewhere. The cluster has also been granted this kind of Finnish Security Award way back, but like kind of the idea of having this safety and security cooperation has been there from the start, and that was recognized. And the way we are operating so that the coordination, there is kind of a host organization always for the coordination, and the host organization, currently Business Tampere, is handling these kind of operations for the webinars and so forth. Earlier in the start, Polish University College was in this coordination role, Jouni Perttula there, then Tampere University of Applied Sciences with Petri Murtomäki, Risto Honkonen until last year from Tampere University, and now we are continuing this as noted. If you look a little bit on the membership or members of the cluster, we have not been formally kind of collecting the signatures on membership until recently, like last 2 years or so. So when we look at this picture, we see somewhat like 30 organizations. They are nicely distributed. There's public organizations, there are companies, there are research institutions and so forth. And these are the current members. But of course, if you look at the whole region and if you look at kind of how many organizations were involved last year in the cluster operations, I think there was more than 100, and that group comes from this kind of ecosystem view. So how we set up these events and operations is such that the almost all of the operations are available or to the whole ecosystem, and also for organizations outside from the region as we are open for collaboration. But then the membership, they are more involved in looking forward how we evolve the cluster, what kind of activities we will be doing in the future. But I do kind of recommend considering the membership, and you can contact me on that if you are interested. The operational model of cluster is such that we have this annual cluster members meeting, and there are certain decisions like the coordinating party, budget when needed, and so forth that are decided there. We have management group that is having meetings maybe from 2 to 4 times, around 3 times a year, and the management group approves new members, for example. Then I'm working as the director of the cluster and looking after how we set up the operations and how to coordinate the operational work. And the operational work we last year decided, and we for this year are implementing this kind of a new work division, that this kind of a communications, marketing, business development, helping companies and setting up events, coordinating that. We are handling that from Business Tampere, And then what comes to research and education development, Tampere University has lead on that. And then the Council of Tampere region has lead on national and international networks and regional promotion. So we are kind of dividing a little bit of the tasks so that we have kind of 3 tracks running all the time next to each other. And then if you look at the administration of the cluster, I mentioned the management group. So here you have the names. I will not call them one by one, but names of the management group, the chairman being Esa Halme from Council of Tampere region and Matti Helen, vice chair from Securitas. Then I'm acting as the director of the cluster and handling the communications, marketing, business development track. The research and education development, as said, the responsibilities with Tampere University, and Risto Honkonen, who was previous coordinator of the cluster, is taking care of that topic. And then Mikko Koponen, who is present today, and Marko Mäkinen from Council of Tampere region are looking at the national international networks and regional promotion. Then if you look a little bit on the activities, on the communications, marketing, business development track, we are basically doing this kind of things that the operational mode change that I'm now talking about. We are setting up based on that, and then we are also, as we had last autumn, workshops and questionnaires and whatnot on how to develop the cluster forward. We had feedback that people were kind of expecting or asking for more communications and more established channels. So what we have done, we have set up a newsletter, dedicated newsletter for the cluster, and we have also set up this kind of a digital platform, and the links are here below. So if you want to get to the posting list, we have the link here, and we can probably drop those in the chat as well. And then we have the digital platform where we have the safety and security network, where we have now like around 100 people out there, and we invite you to come online as well. Also, what we are working on is that as soon as the Horizon Europe kind of topics are frozen and communicated, we can work with companies on Horizon Europe topics and trying to find or establish consortia there. And of course, the research or this kind of setting up this consortia, Tampere University is leading that, but like we are in a way making sure that we get the right companies involved, and it's based, of course, their own interest whether they participate or not. As Business Tampere, as the regional economic development agency, we have a lot of different services, and it was also planned that we will introduce some of those services also to safety and security cluster organizations and in these events. And of course, like these webinars, we are starting now again from last year or so, and then we are going to look at the kind of these new members and discuss on what does that mean. Then we will go to the research and education with Risto. So Risto will be describing this area.
Okay, thank you, Petri. You can see there the slides about concerning the main activities of the cluster in the field of research and education. But maybe some words about the institutions behind all this. I come from the Tampere University. That is now the second biggest university in Finland, and also the most popular university among the applying students. All the faculties have some kind of connection to safety and security issues. So it has these topics have quite a big role in the research agenda of the university, and also in the field of education. But in the cluster there are also 2 other higher education institutions: the Polish University College and the Tampere University of Applied Sciences. Of course, both of them operate as well in the field of safety and security. And worth mentioning is also VTT Technical Research Center of Finland. That is a remarkable player in the field of safety and security research in international scale as well. I want to use here the opportunity also to mention the 3rd Safety and Security Research Symposium that we are organizing on Wednesday, 8th of September this year. It will be an online event only, but in the future, these events hopefully can be arranged in hybrid form, so that the participants who want and are able to come to the site too can do that and meet also physically, meet each other also physically. Anyway, now we are just in the planning phase of the event, but we already know that the keynote speaker will be Dr. Teija Tiilikainen from European Center of Excellence from Countering Hybrid Threats. Her topic will be new security threats and how to address them. There will be also 12 thematic sessions in various themes: cybersecurity, safety and security of autonomic systems, resilience in educational institutions, fire and rescue safety, aerosol safety, resilience and crisis preparedness in Finnish health system, event security and safety, crisis management, education and eco-crisis, environmental safety. So important topics, all those. The event will also be the 10th anniversary event of the Tampere Region Safety and Security Cluster. So Petri, I think this is enough for now. Time is running.
Very good. Thank you, Risto.
Thank you.
And then we will continue with Mikko.
Thank you very much. Like Petri already introduced me, I'm a representative council of Tampere region, and our responsibility in this cluster is basically networks and promotion of regional interest. And this slide here, what you can see is what we are doing in general in the cluster. But this year we are working for, or more likely we are contributing this agenda here with 3 focus areas. And firstly, we are updating our regional development program as we speak. And why this is worth of mentioning is because it will basically give us the strategic backbone for allocation of different regional development funds for the projects. And of course, it provides us major themes to be promoted in a national level, for example. And the big idea here is to include safety and security somehow to the program as a horizontal kind of objective. Second thing good to mention is this ongoing national health and social services, rescue services reform, where the responsibility of the services will be transferred to these new counties. And these new counties will be really interesting platforms. They will be really interesting actors in the field of safety and security, and especially great addition to our cluster, security cluster. So basically, we will, in the Council of Tampere region, we will follow the reform very closely and try to spot all fruitful, interesting opportunities into our cluster's usage. And thirdly, I have to mention this Ensure collaborative network, which is kind of European mother cluster for security clusters. And actually, Tampere region cluster is one of the founder members here. And it was just launched a few weeks ago, if I remember it correct. But I think Petri or Risto, they can tell you more about this Ensure network. That's about all from my side. Thank you.
Okay, thank you, Mikko. Like the Ensure collaborative network is there's like 9 regional or national level clusters of safety and security, and like the Hague Security Delta, the SAFE cluster and from France, Sensec from Denmark, SCS cluster from southern France, Tampere Region Safety and Security Cluster, Space 53 from Netherlands, and Security Network Munich from Germany. I guess like I would say that this kind of a network, it gives as much as we put time in, but like the idea is that we could utilize this network for finding collaborating partners, for example, for different Horizon Europe topics and consortia, and that has happened in the past with some of these, and I believe that is one practical thing. Another thing is then to really look at on the company level, like what would be the potential partners between the regions, but like we will come back to that, but like it's also good for visibility of our cluster to be in this group of clusters. But thank you, Mikko. Let's move forward on the agenda. We are running a little bit late, but like now what we are doing, let me see. I don't see if there's any questions. So Anne or Petri, you can indicate if there are or not.
No questions at the moment, and I think if there are, we could continue in Prella side. Right.
So what we do next is that in the Prella, you see on the left side menu, you see the breakout tab, and please select that one. So when you go there and you go to that breakout session or breakout room, it works similarly at Teams. So anybody can ask for discussion or question, and we can kind of make this more interactive. I would also remind you that please do check the Prella one-on-one networking, as I know that almost everybody said that yes, networking is always something we want to do, and we now have the breakout room for discussion, but also look at that possibility of one-on-one discussions. And I set for you target that please set up at least one-on-one session, if not for nothing more, just to check out and test like how this kind of a thing works, so that next time it will be more lively. But now we go to the breakout room and continue the session there. And also all the presenters, please sign off from the Zoom and move to Prella for this discussion. Thank you. Anne, do you have any additions or?
No, this was really good. So let's change the platform and continue in Prella.
Very good.